Okay, guys, once again, I welcome you to my lesson for today. For those who are new to my online lessons, surely by now you do know very well that my name is Desmond, and I hope you will enjoy today's lesson. So I just want to quickly go through the homework that I've given you guys, which is what we'll be focusing on for today's lesson. So let me quickly check. Is there someone who remembers what was the first question? Let me see. Guys, Shreyas, are you there? I want to.
Yes, sir.
Yeah, I want to get to that.
So the first question, sir, that was 10 to the power of x times 24 to the power of x plus 1, all that over 5 to the power of x times 50 to the power of x minus 1.
So number one, you say it was 10 to the exponent x. What is it? Is it a plus in between?
No, sir, it's a dot.
Okay.
Time.
Then it's 15.
25.
Oh, no, it's 25. Okay. So it's 25 to the exponent x plus 1
Yes,
over 5. Is it 5?
Yes, sir. X.
5 to the exponent x multiplied by
5,
it's
50
50,
to the exponent x minus 1.
X minus 1, 100%. So this was the first question of the homework that I gave to you on our previous lesson. So, ladies and gentlemen, if you remember, before we did this lesson, I taught everyone on how to apply the maths basic rules. So, in today's lesson, we'll be looking at let me see. We'll be looking at this homework that I gave to you to apply those math rules in order to answer these questions. So remember, guys, this is what we call simplified type of problems, where you are given the whole of that and you need to write it in its simplest form. So guys, obviously, you want to write everything in its smallest form, especially the basis. So you want to write the basis in their simplest form. So can we rearrange that 10 such that we have the smallest basis of 10? So obviously, I think 5 multiplied by 2. This is 10, isn't it?
Yes.
Guys, are we still together?
Yes, sir.
So remember, I haven't changed anything. What I did was just to expand that 10 as the base, multiplied by into what makes 25, remember, to the exponent x plus 1. So 25, what is it? It's 5 multiplied by 5, isn't it?
Yes, sir.
It's 5 multiplied by 5. The whole of that divided by. So you've got 5, which is that one to the exponent x. What makes 50? Let me see. What is it? It's 2 multiplied by 25, isn't it? So 50, it's made by 2 multiplied by 25. So I'll just write 25 over there to the exponent x minus 1. So remember, guys, I deliberately made this step just so that I show you something, guys. Remember, there are multiple ways in which you can approach this type of problems. So it all depends on what works for you. So it's not only this step which can be the first step to that problem. You can also approach it in a different way. So this is one of the ways in which um, you can approach that type of a question. So this is not the method that I'm going to continue with. So I want you guys to be exposed to different types of methods in which you can approach a question. The other method, remember, you've got 10 to the exponent x over there. So now let's expand the whole of that. Let's expand the whole of that, because we know in between we've got multiplications, we don't have addition or subtractions. So that means you can expand the whole of that as 25 to the exponent x multiplied by 25 to the exponent 1. Based on our previous lesson, you know very well that when you've got the same basis, you can add the exponents, of which it takes you back to that that part over there. So the whole of that can be divided by 5 to the exponent x multiplied by 50 to the exponent x multiplied by 50 to the exponent negative 1. So remember, all I'm doing is just to rearrange the base such that I'm separating the exponents over there. There's a rule that we're applying. I'm very much sure that for those who attended my previous lesson, they are aware of that rule. So now what you can do in this case, this is where you can focus on the basis, because already you have separated the exponents. So that's why previously I said what makes what makes a 10, of which we know 2 multiplied by 5, it makes 10 inside the brackets, which is the 10. So we can also do the same for for that 25 over there, or otherwise we still have an option to just leave it as it is. The reason to that is because we already know that we've got 50 that we can also expand or separate. But for the sake of remaining consistent, let's just dissolve the bases to their smallest numbers. So obviously, what makes 25? Is it 5 times 5? 5 times 5 is 25. Remember to write the exponents as they are. Multiplied by 25 to the exponent 1 obviously is the same as 25 to the exponent 1, or is the same as just 25, because we already know we've got that invisible 1 over there. So at the bottom, we've got 5 to the exponent x. We cannot dissolve that 5. It remains as it is. So multiplied by, what makes 50, guys? What other numbers makes 50? I know 25 times 2, it makes 50. But what other number, when multiplied together, gives 5 and 10? They also give 50. Let me say 15. Okay, 5 and 10 gives 50. 5 and 10. So that means now I can say 5 multiplied by 10. What other numbers give 50 divided by 5? 10, 25, and 2. Okay, then let me use 5 multiplied by 10 to the exponent that x over there, multiplied by 50 to the exponent -1, which is that one over there. Guys, I'm not really sure if so far there's someone who's left behind, or otherwise if there's someone who's got a question based on what I've done so far. Anyone who's got a question, guys?
No, sir.
So that means I'm in line with what you've been doing on your homework, isn't it? No one is lost so far, isn't it? Okay, so remember, guys, that 10 over there can also be further simplified, because we know what makes 10 is 2 multiplied by 5. So instead of writing 10 over there, let's same time just write it as 2 multiplied by 5, which means when you punch 5 times 2 times 5 on your calculator, it has to give you 50. So let me see, 2 times 5 times 5, it gives me 50. Remember, guys, the aim is to have the basis of these bigger numbers in their simplest form, or in their smallest numbers. For example, it's 2 multiplied by 5. These are the smallest numbers which can be multiplied together to give 10. So now we apply that rule where we say the exponent multiply the exponents, the exponent multiply the exponent, exponent multiply the exponent. So let's see, that means we've got 2 to the exponent x multiplied by 5 to the exponent x. Remember, there's that invisible 1 over there and there. There's an invisible 1 there, there, and there. So you are multiplying 1 by x, which gives you x. 1 by x, it gives you x. Multiplied by, you've got that 5 over there to the exponent x. Multiplied by 5 to the exponent x. Someone please unmute, mute your mic. Then we've got 5 to the exponent x, which is that x over there. Then that x also, it's going to multiply the exponents of everything within the brackets, which means we're going to have 5 to the exponent x multiplied by 5 to the exponent x multiplied by 5 to the exponent x. Over there, I think I said it's 5, even though it has to be, what is it? It has to be 2, multiplied by 50 to the exponent -1. So someone might be asking themselves a question to say, why am I not dissolving that base, which is 50? So for now, it's not really necessary to dissolve or work out that 25 and a 50, because it's just a number without a letter. So I'm only focusing on those numbers with letters. So that is the reason why my focus is only on those numbers which has got an exponent with a letter. So at this stage, I can cancel out those that cancel out, or otherwise, work out the numbers. So obviously, let's check. At the top, we've got 2 to the exponent x. At the bottom, we also have it there. Then we cancel. Then what else have we got? We've got 5 to the exponent x. They cancel. 5 to the exponent x. They cancel. 5 to the exponent x. They cancel. So now that means I'm remaining with 25 over 5, 50 to the exponent -1. Remember, guys, there's that rule where we said we always want to write the positive exponents, which means 25 it's already with a positive exponent of 1. Then you just multiply with a positive exponent of 50, which should be equals to 25 multiplied by 50 with a positive exponent. So let's see what answer we are getting when we multiply 25 by 50. We're getting a very big number over there, which means this is our possible final answer. And what I like about this type of problems is because we are able to test if our final answer is wrong or correct. So guys, is there someone who also got 1225 for this question as their final answer?
Yes, sir.
Who is that? Who got that answer?
Lerato, sir.
Anyone else got the same answer, guys? Let me see who's on the line. Promise. Shreya Slebo. I know Tanto, it's her first time. Azinga, it's her first time. Guys, for those who attended that previous lesson, is there someone who also got a similar answer? I assume it's a no for that question. But let's now try to prove it. Remember, guys, I said the final answer is 1250. So the final answer for question number 1, it's 1250. So I said for this type of problems, if you want to prove if your answer is wrong or correct, you need to substitute that final answer in place of X from the original problem. And when you substitute X there with that number, you must get that same final answer. If you don't, then it means it's either you punched incorrectly or otherwise you made a mistake somewhere. So let's all punch all of this on our calculators, guys. So this is a multiplication sign, 25, 1250 plus 1 all over 5 to the exponent 1250 multiplied by 50 to the exponent 1250 minus 1. So when we punch all of this on a calculator, we must expect to find that answer. If we don't, Lerato, it means our answer is incorrect. So let's see. Whoever who gets that same number, just make a comment. Remember to first mention your name, and then from there, confirm for us if you got the same answer. So it's fraction button 10 to the exponent 125. Let's see, then it's a times 25 to the exponent 150. It's plus 1 at the bottom of port 5 to the exponent that multiplied by 50 to the exponent 1250 minus 1. 1250. No, let me do that. Guys, is there someone who's done? Shreyas, is that you?
It gives error.
It gives error, ne?
Yes, sir.
Let me see. Okay. It gives error, ne? Let's try to put, because now the whole of that, it's a multiplication sign. So let's try to put all of this in brackets. Because I think I've noticed why it gives that error. It's because of that bigger exponential number over there. But let's try it this way to say 10 to the exponent 1250 close into 25 to the exponent 1250 plus 1, 1251 close to the bottom into 5 to the exponent 1250 close open 50 to the exponent 1250 minus 1 still gives an error. Now are you guys still getting an error?
Yes, sir.
Yes,
So
sir.
yeah, so I also agree. So that error, we do have to get an error because of the answer, our final answer, which we are substituting there on the exponents. It's a bigger number. So now it means I need to show you a second method of proving if your final answer is correct. And it applies in these instances where you've got that bigger number and you are not able to confirm if your final answer is correct. So now we test using a smaller number. So a smaller number could be, let's maybe use 2. I'll show you how you use a different number to prove if your final answer is correct. Shreyas, you remember that
Yes, sir.
when you simplify, nothing changes. It's still the same thing. It's only that it's being written in its simplest form. Do you agree?
Yes, sir.
So, which means from that original equation, if we say 10 to the exponent, let's say we use 2 to test, then wherever we see x, we substitute a 2. Then let's say that obviously it's in brackets or otherwise multiplication in between. Then we say 25 to the exponent 2 wherever we see x. Then at the bottom, we've got 5 to the exponent 2 into, we've got 50 to the exponent 2 minus 1. So this is where we substitute the whole of that with 2. And then from there, because we are saying when we simplify the whole of this, everything going down is the same. That means even when we substitute 2 there, or you can substitute it there or there, but we have to substitute it on the last step that has x, because we just expanded everything over there, which means obviously there on that step it's only a number. There's no way you can substitute 2. So that means on this step, this is where we must substitute 2 and get the same answer as when we substitute from the original equation. So guys, I'm not sure if you've got a question based on what I'm explaining now. In case if there's someone who's got a question, you can just ask me and then I will further explain so that you understand. So I've got 5 to the exponent 2, 5 to the exponent 2, and then there is 25. Then we substitute it again. There's 5 to the exponent 2. That one there is 5 to the exponent 2. This one is 2 to the exponent 2. And then there we've got 5 to the exponent 2. That one there is 50 to the exponent minus 1. Guys, I'm not sure if all that I've explained so far, it makes sense. Let me see. Ntando, are you Azinge? Are you guys following? Are you guys with us on the same pace?
Yes, sir.
Yes, sir.
Okay, so let's try to substitute all of that punch all of that on our calculator and also punch all of this on our calculator and check if we're getting the same answer. So whoever who gets an answer, just say the first one, mention the number that you get, then I'll write it, then we'll also punch this one. If we get the same answer for both, it means our calculation is correct. If we get different numbers, then it means it's wrong. So that is the second way that you can use to prove if your simplification is either correct or wrong.
So the first one is 2.
So the first one, we're getting 2. And then the second one,
Sir, it's 125.
you're saying you're getting for the
125.
second one.
125.
So
1,250.
for the first equation says 1,250.
And the second equation is 1,250 as well.
Wait, you're saying for the first one, how much are you getting?
1,250.
1,250.
Yes, sir.
And then the second one,
1,250.
1,250.
Yes, sir.
Oh, so two of you guys for the first one are getting that number, and again, you are getting that number, ne?
Yes.
Which is promising. I'm not sure whoever who got 2 and 125, you might need to check if you maybe you made a mistake when you punched somewhere. So I'm sure I heard Lerato and Tria's voice saying they got 1,200 and 1,200. So Trias and Trias and Lerato, in place of 2, where you initially substituted 2, substitute with 5. I want to test something. Do the same calculation for both, but substituting with 5. I want to check something which is going to help us to make a conclusion on this one. And whoever got 2 and 125, try again to repunch the whole of that and check if you haven't made a mistake somewhere. I'm also punching on my side. I want to see what answer I'm going to get. So 50 to the exponent negative 1, close bracket. For this one, I'm also getting 1,250. So I'm going to do the one at the top, which is 10 squared, close 25 to the exponent 2 plus 1, which is that the bottom of 5 squared 50 to the exponent that minus that. Wait.
So
No. Yes, Rias?
So with the exponent 5, so in the first equation, so it gives me 2 over 5.
On both equations, you are getting 2 over 5.
So just want to check the other equation, sir.
Okay.
The second equation, it's 1,250.
For which one? For this one?
Yes, sir.
You are getting still the same answer.
Yes.
And then, now you're about to do that one, eh?
Yes, sir.
Okay.
I'm getting 1,250, sir.
So you're still getting the same answer when substituting with 5.
Yes, sir.
Guys, the other guys, Ntando, Promise, are you guys still getting the same answer, or are you getting different answers?
No, sir, it's 1,250.
So it's 1,250, ne?
Yes.
So can you see, guys, it's more like based on what I'm detecting, we'll try to check with a different question. It's more like if you are given this which is something that you need to simplify. If you get a bigger number whereby when you try to prove it and you don't get a, maybe it gives you an error, then you can try using a different number, whether you use 5, 10, -11, or whatever number that you use. When you substitute it there in place of x and also substitute that last step with x, you must still get the same answer. Or otherwise, if it's a different answer, then it's either you made a mistake when you're punching on a calculator, or otherwise somewhere there you've made a mistake. But so far, based on your calculations and also what I've calculated on my side, I feel like that 1,250 is the correct answer. I'm not sure before we move to the next calculation, in case if there's someone who needs clarity on that first question. Are we all satisfied on that question?
Yes, sir.
Sir.
Okay, so let's now move to the next question. Someone try to check what was that question. So what was that question number 2?
It was
So it was
6 to the exponent of n plus 2.
Let me see who's speaking. Okay, Promise. Read it out and the rest just check if we're not copying it incorrectly. What is it, Promise?
It was 6 to the exponent of n plus 2 multiplied by 10 to the exponent of n minus 2.
N minus 2. There you're saying, what is that one? 6 to the exponent?
N plus 2.
Oh, n plus 2. Okay.
Divided by 4 to the exponent of n.
Mm-hmm.
Multiply by 15 to the exponent of n minus 2.
N minus 2. So it was like that, ne?
Yes.
Okay. So, ladies and gentlemen, when you're given this type of a problem, remember, based on my previous question that I did, I was more interested in firstly expanding the whole of that. What do I mean by expanding? Let's say we've got 6 to the exponent n multiplied by 6 to the exponent 2. I'm just separating those exponents multiplied by 10 to the exponent n multiplied by 10 to the exponent minus 2. There's nothing tricky that I'm doing over there. I'm only interested in separating the exponents multiplied by 15 to the exponent minus 2. So all of us are on the same page on that one, I assume. So now the next step that I'm interested in doing is now to write 6 using the smallest 2 numbers that I can multiply and they give me 6. What are those numbers, guys? I think, what is it? 2 multiplied by 3 will give you 6. Most importantly, remember, guys, this is just a number. So there's no need for you to expand that 6 because you know 6 squared, it's a certain number. You can either write it as 6 squared or as that number. Let's see, what is 6 squared? 6 squared, it gives 36. For example, you can now say 36 multiplied by, what about 10, guys? What are the 2 smallest numbers when multiplied together? They give you a 10. So
5.
this is it. It's 2 multiplied by 5. Then 10 to the exponent minus 2. You can just write it as it is, just like you did with 6 to the exponent 2, or otherwise 36. So this one, because it's a negative exponent, you can just write it as it is, because when you punch it on a calculator, it's going to give you a decimal. For you not to get confused, you can just leave it as it is. And again, obviously, you know, when it comes to 4, you can say is 2 multiplied by 2 to the exponent n. And again, 2 squared is equals to 4. Then I just avoided using this method because I'm going to end up having 2 to the exponent 2n. So I just want to have 2 to the exponent n. 2 to the exponent n multiplied by 2 to the exponent n, because I realize at the bottom I'm going to also have 2 to the exponent n, which will easily cancel out. So it's better if you separate the exponents. Again, with 15, what is it? It's 3 multiplied by 5 to the exponent n multiplied by 15 to the exponent minus 2. So guys, I'm not sure if so far we are still on the same page. Two of you to confirm if you are not lost.
Yes, sir.
We are fine, sir.
100%. So now, obviously, we multiply the exponents, which means we're going to have 2 to the exponent n multiplied by 3 to the exponent n multiplied by 36 as it is, multiplied by 2 to the exponent n multiplied by 5 to the exponent n multiplied by 10 to the exponent minus 2. The whole of this is divided by 2 to the exponent n multiplied by 2 to the exponent n multiplied by 3 to the exponent n multiplied by 5 to the exponent n multiplied by 15 to the exponent negative 2. Ladies and gentlemen, I want to remind you of something. Can you see that 10 to the exponent negative 2, 15 to the exponent negative 2? Remember, guys, there's that rule which says if you have got a to the exponent n over, let's say you've got b to the exponent n, because we always want to have a positive exponent. That means if we have a negative exponent at the bottom, we take it to the top, then it becomes b to the exponent positive n, then you take a to the bottom and write it as a positive exponent. Guys, I'm not sure if you remember this rule. Do you remember, guys?
Yes, sir.
If you remember the rule, let's apply it, which means this 10 to the exponent negative 2 and that 15 to the exponent negative 2. We can then write this one at the bottom with a positive, that one at the top with a positive. So I'm simply trying to say, guys, we simply have 15 to the exponent positive 2, and at the bottom we've got Azinga. Can you mute your mic? Then at the bottom we've got 10 to the exponent 2. So guys, does it make sense what I've done over there?
Yes, sir, it does.
100%.
Yes,
So now let's check. Can we try to cancel those that cancel out? Let's see, we've got 2 over there. We can cancel it with that one. What else do we have? We've got that 3 there. Do we have a 3? Yes, we do have at the bottom. Let's see at the top, we've got that. Yes, it cancels out with that one over there. Do we have this one 5? Yes, we do have. And that one at the bottom we do have. Then can you see those with exponents n, all of them, they cancelled each other out, and we are left with 36 multiplied by 15 squared over 10 squared. Then you can either punch the whole of this or just work out 15 squared, which is, it's more like it's 36 multiplied by, if you punch on a calculator 15 squared, I think this is what you're supposed to get. Then at the bottom, 10 squared, I think it's 100. Then this is 100. Then you can punch all of that. Let's just see, is 36 multiplied by
81.
225.
You
At the
answer.
bottom, it's 100. So it's 81. Eh?
Yes.
So, ladies and gentlemen, can we also try to prove if 81 is correct? While I'm writing it down, please do try to punch all of that on a calculator. So that means we're having 6 to the exponent 81 plus 2.
It's sir.
The whole of that. Have you punched it already, Rat?
Yes, sir.
That 1581 minus 2. What are you getting, Rat? Are you getting 81?
Scientific error.
It says error again.
Error, sir. Yes.
Yes.
Let me also see on my side. So is that 81 plus 2? Close
That's an
that
error.
10 to the exponent 81 minus 2. Close. At the bottom is 4 to the exponent 81. Close. No. I have to close at the bottom. Then it's 15 to the exponent 81 minus 2. Let me go up and close that bracket, the whole of it. And also go to close. Okay, it's equals to, then it gives an error. So, yes, I agree with you when you say it gives an error. So now, let's try to use that method. Can someone use, let's say 4, and the other guys, let's use 2, no, not 2, but let's use 3. Not even 3, let's use 7. So, wait, before you punch, let's check where else are we going to prove that answer. On which step? Let's say this is step number 1, step number 2, step number 3, step number 4. From step number 1 up until number 4, which step can we use to prove using either 7 or 4? Guys,
17.
is there someone who wants to guess which step
7,
can we
sir.
use? Which step?
So we can use the third equation, sir. Third step. Or we could use
100%.
the
So let's use equation number 3, or otherwise step number 3. So Shreyas, you can use 4, number 4 to prove. Substitute it on that and also on this one. And then who else? Lerato, use 7. Promise, use 4. Who else is on the line? Ntando, use 7. Promise, use 7. Lebu, use 7. Kele, use 4. Moro,
Sir, must
something, use 4.
Sir, must use
So-
7 or 4, sir?
Who is it? Is it Shreyas who's asking?
Yes, sir.
No, you can use 7. So
Okay,
you are
sir.
going to substitute it there and again there. So let me try to rewrite that third equation so that it's clear, because I noticed we were doing some cancellations there. So it's going to be
Sir,
2.
I'm getting
Mhm.
81. It's 81, the first equation.
Who is it? Who is it? Who's speaking? So which
Yes.
answer are you getting? You're getting 81.
Yes, sir. I used the
When you
first
substituted the first, okay, which is promising. Let's try to check when you use that third equation. So guys, it seems like the key is that first or original equation. When you use that original equation, it has to give you that it doesn't matter whether you're using any number. So Lerato, that means even if you use maybe 1,000, 1,000 is a big number. Let's avoid big numbers because we noticed when we get our final answers as big numbers and we substitute on exponents, it gives an error. Use -11, Lerato. Use -11 on that original equation and expect to get that same answer, regardless of whether you are using that last step or that equation. Whatever equation that you use, you must get that 81. And I've just noticed something, guys. The reason why when you substitute on that original equation and you must get 81 is because everything with letter N, it cancels out. So it doesn't matter whether on that exponent it's a million. So in place of N, if it's a million, then you are also going to have a million at the bottom. Million on that 3, million on this 3, million on that 5, million on this 5, million on that 2, million on this 2. They are going to cancel out anyway. Then you are going to remain with these numbers. Guys, I'm not sure if it makes sense now.
Yes, I'm getting 81.
You are getting
sir.
81 even when you use -11, isn't it?
Yes, sir.
So guys, I've discovered something which is very, very, very interesting. Let me just try to check someone. Ntando, are you able to unmute your mic and speak? Kele, can you unmute your mic? I want to explain this to you so that everyone else can see if they understand. Kele. Ntando, okay, Ntando unmuted him. Ntando, are you able to speak? Can you hear us?
Yes, sir.
Okay, check. Ntando and everyone else, this is what I'm explaining. On our next question, question number 3, this is what we're going to do, which is something that I've just discovered now. Before we simplify the whole of this, it means if we can use maybe, let's say, 2 to substitute there, whatever number that we get when we punch the whole of this, it must be the number for our final answer. I'm not sure if you guys understand this part.
Yes, sir.
Lerato, you understand what I'm trying to explain, isn't it?
Yes, sir.
Yes.
So let's try to move to third equation. Then it will make even more sense for everyone. What was the question number 3? Who's giving me that question for number 3?
Sir, it was 6 to the exponent of x.
So you're saying 2 to the exponent x, ne?
6.
6.
It's 6,
6.
sir. 6.
6.
Wait, let me try to see if I can log into the group using
Sir,
a different.
it's 6 to the power of x.
Oh, you're saying 6, ne?
Yes.
To the exponent x
Oh, okay. No,
multiplied by
I was able to log in. Okay. All right. No, guys, I was able to log in using a different phone. So I'll quickly write it down. So it's x to the exponent that multiplied by 9 to the exponent that multiplied by 2, the whole of that to the exponent 27, x plus 1 multiplied by 2 to the exponent x minus 3. So guys, based on what I've explained, I was saying in place of x, whatever number that we get when we substitute it should be our final answer. Let's run a test, guys. Let's see. Promise, use number 2 to substitute there. Shreyas, use 3. Lerato, use -12. Let me see who's on the line. Promise, Ntando, Azinge. Okay. Let me see. Promise, use 4. Let me see. Whoever Azinge, use 5. Legu, use 7. I just need a confirmation from 3 of you guys. Just use any of this number and substitute it wherever you see X and let me know what final answer you are getting. So whoever uses whatever number, we must get the same answer. Let me also use a different number and punch on a calculator. So I've got 6 to the exponent. Let me use 9. 6 to the exponent. Myself, I'm using 9 multiplied by 9 to the exponent 9 plus 1 multiplied by 2. I hope that 9 is not a bigger exponent. 27 to the exponent 9. Is there someone who got an answer already?
Yes, sir.
What are you getting?
I'm getting 4/3. I used negative 11.
I'm also getting 4/3 with my 9.
So I'm
4/3, Lerato.
4/3.
You're also getting 4/3, ne? So all of us are getting
It's
4/3, isn't it?
Yes.
So guys, this is an interesting discovery of
4/3,
which
sir.
100% consider yourself lucky, guys, because I wasn't aware of this thing until today when I realized when we're trying to prove if our final answer is correct. Ntando, what does it
Yes,
mean
sir.
if we get 4/3 as our final answer? Do you want to guess what does it mean for us?
It means that the x's will cancel. The x's at the bottom will cancel the other x's at the top.
Okay, and then it's a response which is not wrong, but it doesn't answer my question. Let me also try to get someone else. A Promise, do you also want to guess?
Yeah, so let me try.
Say again, Rato. I mean, Promise, what did you say?
I think maybe our final answer will be 4/3.
100%. Who Ntando? Remember, in your case, I understand because I think this is your first lesson. So in that Telegram group, you'll need to scroll up and check for a link where I was teaching this maths basic rules. I think I've also emphasized it in that lesson that we had on Friday. So guys, in short, it means whatever that we used to substitute there, we used different numbers, we got the same answer. That means when we simplify the whole of this, our final answer has to be that answer. So Ntando, you are right. It means towards the end, those with exponents of x will cancel each other out and we're going to remain with 4/3. So let's see. Remember, for those of you who are making notes, let's say for simplification, the first step maybe is to separate the exponents. If you're making notes, you can say separate exponents. Step 1 of simplification. Let's separate. So we've got 6 to the exponent x multiplied by 9 to the exponent that multiplied by 9. Obviously, you know there's that invisible 1 over there multiplied by 2 to the exponent 27 to the exponent x multiplied by 27. There's invisible 1 over there, 2 to the exponent x, 2 to the exponent minus 1 over there. So now that we have separated the exponents, we can now work out the bases. So when you work out the bases, you want two smallest numbers when multiplied together they give you 6. What are those? Is 2 multiplied by 3 to the exponent x. For 9, what is it? Is it 3 multiplied by 3 to the exponent x? Then because these two are numbers, you can just multiply them together and they give you 18. Otherwise, you can leave them as they are, but towards the end, you will eventually multiply them together. So it's better to just simplify everything where possible. What about 27, guys? What two smallest numbers when multiplied together, they give 7? Someone to assist before I keep on calculating. 4 is 3 multiplied by 9. So 3 multiplied by 9, it gives 27. But remember, I still have that 9, which is 3 multiplied by 3. So it's better to just write 3 multiplied by 3 multiplied by 3. Guys, does it make sense what I've explained just now?
Yes, sir.
Okay, so 27, no need to expand it. You can just write it as it is because it's just a number without an exponent with an x. So you can say multiplied by 2 to the exponent x, you write it as it is. Remember, guys, you can choose to write that one at the bottom as that, or otherwise take it to the top with a positive exponent, applying that rule. You remember, guys, I hope you remember this very well. So now let's multiply the exponents. So this is your step 3 of making noise. Firstly, you separate the exponent. Secondly, you work out the basis. And thirdly, you multiply the exponent. That times that. So you've got 2 to the exponent 2. You've got 3 to the exponent x. You've got 3 to the exponent x multiplied by 3 to the exponent x. And then this 2, what is it, guys? Is it 33.6? Just confirm if it's 36. Then you've got that, which is 3 to the exponent
Yes,
x, multiplied by 3 to the exponent x, multiplied by 3 to the exponent x. 27, you can just leave it as it is, guys. It's just 27. Then you've got 2 to the exponent x. So, Ntando, this is that part of you answering my question. But can you see your answer did not respond to my question, to our final answer, even though I said it's not wrong, but it's a correct answer? Or maybe the best way of doing it so that you don't make a mistake, let's start with that 2 and say there's that 2 and there's also that 2. Then we cancel. Then there's 3 to the exponent x, it cancels with that 1. 3 to the exponent x cancels with that 1. 3 to the exponent x cancels with that 1. Then you've got 36 divided by 27. If this does not give us that, then it means everything here is wrong. Let's test it, guys. I hope
So it does
it
give
gives
4
us.
over 3.
Does it give 4/3 for everyone?
It's 4/3, sir.
36.
4 over 3.
4/3.
4/3.
100%. 4/3. So can you see, guys, that what we've discovered today is massive? Can you see how massive is this method, guys? I think it saves us a lot of time of trying to prove using that and also that thing over there. So let's now move to the next question. But before we do, are we all on the same page, guys? Am I not too fast for you to understand over there?
Hey,
No, sir.
say,
No, sir.
Okay, so
say.
remember, guys, for those of you who are attending my lessons for the first time today, we've been doing multiple lessons where we know how to deal with certain problems. So in case if you're falling behind, don't be ashamed to ask any question, because what I've learned is that when you are grouped together like this, we are able to learn from each other through questions. And again, when I was going through, I'm not copying. No. I'm not copying the next question. I've jumped to the other question. So, guys, I was saying, do not feel ashamed to ask a question, because even with these homeworks that I'm giving you guys, I'm able to then understand how you approach these things. And I also learn from your response. It doesn't matter whether your answer is wrong or correct, but because of your approach, I'm also able to learn how differently we can approach the same problem. So, ladies and gentlemen, did I copy that one correctly? Can someone just confirm if I've copied it correctly?
Yes, sir.
100%. So, what is our first step based on what I've said for those who are writing notes? What is our first step?
Separate the exponents.
Separate exponent.
100%. 8 to the exponent n multiplied by 6 to the exponent that multiplied by 6 to the exponent that multiplied by 9 to the exponent that invisible 1 multiplied by 9 to the exponent that, the whole of this to the exponent that multiplied by that multiplied by the negative 1 over there, 3 to the exponent that. So, ladies and gentlemen, according to our notes, what is the next step?
Work out bases.
Let's work out the bases. Obviously, 8, it's made out of 2
Work
multiplied.
out the bases.
Okay, so 8 is made out of 2 multiplied, is 2 multiplied by 4. But that 4, it's made out of 2 multiplied by 2. So I can just do it that way. Do you guys agree with me on that one?
Yes, sir.
So 6,
Yes, sir.
it's made out of 3 multiplied by 2 to the exponent n. Remember, guys, this one, I can write it at the bottom as 6 to the exponent positive 3. Do you guys agree with me on that one? So I also have
Yes.
that 9 over there with that invisible 1. And that also, guys, do you agree with me that I can write it as 9 9 to the exponent positive n? But remember, before I even do that, I need to then separate all of those bases. Let me also separate for that 6. For 6 is not necessary because it's a number to the exponent number. So that, I wanted to say that one. Do you agree with me that I can write it as 3 multiplied by 3 to the exponent positive n? Does it make sense for everyone, that step?
Yes.
Yes, sir.
Okay, so where am I? Now I can write down everything for that part at the bottom. So 16, what makes 16? What are the smallest numbers making 16, guys? So
2
2
times
to the
8.
power. Oh,
It is
what
2
is it?
times 2 times 2.
2
2
times
times
2
2 times 2 times
times
2.
another 2, ne?
yes, sir.
4 2s.
Yes.
Okay. But wait, guys. Do we really need to do that for... Oh, yes, it's 6 to the exponent n. Okay, yes. Then 16, I can write it at the top as 16 to the exponent invisible 1. Also, that 3, I can write it as 3 to the exponent positive n. Guys, this is a bit confusing, but I'm not sure if we are all on the same page. Or would you like if I remove and redo it, just like we're doing with the previous questions? Does it make sense for everyone?
Yes, sir.
Yes, sir.
Makes sense.
Yes, sir.
Guys, yes for which question?
You can carry also with this one. We understand clearly.
Okay, all right. So I hope we did everything correctly, guys. Based on our notes, what is the next step?
Multiply the exponents.
Multiply the
Multiply the
exponents.
exponents. We have 2 to that, 2 to that, 2 to that, multiplied by 2 to that, multiplied by 3 to that. And then this 2, what is 9 times 16? It's 144. 144 multiplied by 3 to the exponent that. The whole of this. What is 6? 6 to the exponent 3 is equals to 216. Okay, I will do this next. That to that is 3 to the exponent n, 3 to the exponent n, multiplied by 2 that, 2 that, 2 that, 2 that. So guys, let's firstly try to check what answer are we trying to expect. Can someone use a 5 to test? The other one, can you use maybe 3? No, not yeah, no, 3 is fine. Just choose any number, and then the other guys use 5, the other guys use 3. I'll use 3. Let's see what answer we are getting before we get to the final answer. So we've got a to the exponent 3 multiplied by 6 to the exponent 3 minus 3 multiplied by 9 to the exponent 1 minus 3. At the bottom is 16 to the exponent 3 minus 1 multiplied by 3 to the exponent negative 3.
I'm getting
What are you
2
guys
over
getting?
3.
I'm getting 2 over 3.
Over 3,
I'm
sir.
getting 2 over 3.
2 over 3. So let me see. Ntando, that 2 over 3, what does it mean?
It's our final answer, sir.
100%. So remember, it's not necessarily our final. It means our final answer must be 2 over 3. Because someone will be tempted to say, just to do all of this or skip some steps and just say that is equals to 2 over 3. Can you see? We need to work it out such that in the end we get 2 over 3. So we shouldn't be skipping some steps. So let's see, guys. We've got what is it? This is how you cancel. That you look at it, for it at the bottom is that one there, that at the bottom is that at the bottom is that at the bottom is that. We've got 3 to the exponent n, that 3 to the exponent that. Then we remain with 144 over 216. So what is this? Is it the answer, guys? 1, 2, 1,
Yes,
6,
2 over 3.
2 over 3,
Yes,
100%.
Yes,
sir.
sir.
That means we're getting 2 over 3. So guys, can you see how easy these things are? I'm not sure if they are easy or I'm just making sense or otherwise, because obviously you've attempted these questions and you might have noticed where you've been making a mistake. But otherwise, guys, does it make sense so far?
Yes, sir.
Yes, sir.
Yes, sir.
So can we maybe do all of these questions and know that with simplification we are done? We are just remaining with solving for x. Remember, there are this kind of problems where you need to solve for x. Do you guys remember?
Hold on, sir.
Plus 2. Okay. So with this one, you've got a sign in between. It could be a sign of a plus or a sign of a minus. Let's also try to check if our approach applies. Someone use 4 in place of x. Someone use 1 in place of x. So I'm going to use 1. So let's see, we've got 2 to the exponent 1 plus 2 Then at the bottom, you have minus 2 to the exponent 1 plus 3. At the bottom, you've got 2 to the exponent 1 plus 1. At the bottom is 2 to the exponent, 1 plus 2, which is equals to 2. So, guys, I'm not sure what answer are you guys getting?
It is 2, sir.
So you're also, what number did you use?
I use 4.
The last one to confirm?
It's 2, sir.
Okay.
It's 2,
So
sir.
obviously, our first step is to, separate the exponents. So we have 2 to the exponent 2 multiplied by 2 squared minus 2 to the exponent x multiplied by 2 to the exponent 3, 2, that 2 invisible 1 minus 2x 2 squared. So now that, remember guys, let's now have a separate approach to this question. From what you wrote, that one, let's say it applies in case if we don't have a sign of a minus or a plus in between. Because in this case, we've got a sign of a minus. So let's say first step for this type of problems, you separate the exponents first step. Then second step, let's say we also work out the basis as second step. So in this case, there's no need to work out the basis because they are in their smallest form. Then step number 3, let's say we take out common factor. So common factor at the top, we have 2 to the exponent x. Then you say into okay, let's just write it as it is to say 2 squared. Then you have minus 2 to the exponent 3 divided by common factor at the bottom is 2 to the exponent x into 2 invisible 1 minus 2 squared over there. So obviously, then step number 4. Then let's say we cancel common factors. Write that as our notes. Cancel common factors. Then from there, you can simplify the numbers. Don't just punch the whole of this on a calculator. Maybe say 4, 2 squared is 4. That to the power, what is it? That to the power that, I think it's 8. Then here, we've got, what is it? It's 2. Then that is 4. So it's minus 4. So this is the same as that. It's minus, what is it? It's minus 4, isn't it? Divided by 2 minus 4, it's minus 2. This is cancel, that into that, it goes 2 times. So ladies and gentlemen, can you see? Does it make sense for everyone?
Yes, sir.
Yes, sir.
Okay, so let's now move to the next question. It seems like we are all on the same page. Let's see the new guys. Ntando. Who else is on the line? It's only Ntando. Ntando, does it make sense so far?
Yes, sir.
Okay, so 6. Let's move to number 6. We've got 9 to the exponent x plus 3 to the exponent 2x plus 1 divided by, this is 18 to the exponent x. Then we've got 2 to the, guys, remember to always check when I copy if I'm copying correctly. So in case if everything makes sense and again I've copied everything correctly, then we can freely continue. So everything is correct, isn't it?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so let's see. Can you see? Now we've got a sign of a plus at the top. So let's also apply the same approach. So obviously the first step is to separate the exponents. I'm not worried about that 9 for now. All I want to do is to separate the exponents. There's that invisible 1 over there. divided by 18 to the exponent x, 2 to the exponent invisible 1 multiplied by that to the exponent -1. So now that I've done that, I think next step is to then work out the basis. So 3 multiplied by 3 is the same as 9 to the exponent that multiply, it's a plus. Something to be very careful about, guys. This is where it's going to confuse you the most. That 3 to the exponent 2x, can you see? This is the exponent that we need to work out. I'm not sure if you guys understand that this is the same as 3 to the exponent x multiplied by 3 to the exponent x. I'm not sure if you guys agree with me on that one.
Oh, yes, sir.
Yes,
Yes.
I agreed.
Yes, because obviously for it to be 2x, you had to add the exponents. The reason why it might be confusing for you guys is because someone might be thinking to get this thing is only if you've got maybe 3 squared and you've got an x over there where you multiply 2 by x. Can you see? But for 2x or 2 letter, what is special about that one is that you can separate it as x to the 3 multiplied by that. Then you know when you add, you say that plus that, it takes you back to that one. So you need to be very careful when it comes to that one. They like asking where they've got exponent as 2x to check if you're able to separate it. So there, let's also say 3. Do I need to put it in bracket? No, because the base, it's already in its simplest form. So there's no need to put it in bracket. I can just read away, say this is the same as that. Multiply by 3, it's in +1. Remember, guys, whatever that is in a positive exponent, we just leave it wherever it is. So what makes 18, guys? 18 divided by 2. I see
18
3 and that.
9.
It is 2 times 9, ne?
2 times 9.
But 9 can be broken down to what? Is it 3 times 3?
Yes, sir.
Okay. 2 to the exponent, that invisible 1 over there. So can you see we've got a negative exponent there. We can write it at the top as a positive exponent. Do you all agree on that one?
Yes, sir.
Yes.
Okay, so the following step is to work out the exponents, which means we've got 3 to the exponent that, 3 to the exponent that, plus, what is it? 3 to the exponent that multiplied by 3 to the exponent that multiplied by, I can just write this, that invisible 1 over there to the exponent x, the whole of that, divided by what is it? Is 2 to the exponent x times 3 to the exponent x times 3 to the exponent x. Then I've got times 2 to the exponent 1 over there. So the following step, because of that, guys, because of that positive sign, remember, it could be a positive sign or a negative sign. Whichever sign it is, you must get to a point where you take out, the common factor. So, guys, obviously there's no need for us to test what our final answer could be over there, because we already know that whatever number that we substitute with, it's going to be our final answer, isn't it? So let's not do it over then, assume that we agree on that one, and maybe after this lesson you can still do it on your own just to test. So let's try to take out a common factor, guys. This one, it seems like it's going to be an interesting problem. Let's see. 3 to the exponent x, it's a common factor there, isn't it?
Yes, sir.
Yes, sir.
Yes, which means in place of that 3 to the exponent x is the same as 1 times 1. plus it's a 1 times 1 times that 3 to the exponent invisible 1 times 2 to the exponent x, the whole of that divided by nothing changes at the bottom is 2 to the exponent that, 3 to the exponent that multiplied by 3 to the exponent that multiplied by 2 to the exponent 1. So I was just trying to check if the same approach can also work in this case where we take out a common factor. So does it mean our next step, this is where we then cancel out the like terms? I'm trying to check something of which I believe that is how we can work out this problem. I want you guys to notice something. We've got 3 to the exponent x times 3 to the exponent x, which is the same as 3 to the exponent 2. Also there, we've got 3 to the exponent 2. At the bottom, we also have 3 to the exponent 2, of which they can cancel each other out. So there's something I'm suspecting about this step at the bottom, because now when we take out common factor as 3 to the exponent x, it's not correct, because when we multiply that by that, it's more like we remain with 1 3 to the exponent x. Yes, this is not correct, guys. For us to correct it, it means there it's not just 1 over there, but it's going to be 1 for that 3 to the exponent 1 multiplied by 3 to the exponent x, which is that 1 over there. So I'm just going to remove all of this and redo that part, because I noticed something did not make sense. So guys, we can still take out a common factor in the same way that I did, but we are going to do it 2 times. I'm just wondering if I should do it 2 times so that you understand my concern. Guys, what I'm trying to explain, do you understand it, or would you like if I do it in both ways so that you notice what I was talking about?
Sir, please do it both ways.
Okay, so let's take out common factor there, guys. We said it's 3 to the exponent x. So we've got 3 to the exponent x into, what I'm saying is there, I'm still having 3 to the exponent x, not 1 as I did. So with that 1, it was incorrect. Then I'm saying plus, I took that as common factor, which is this one. Whatever that remains, I write it as it is, which is 3 to the exponent x, which is that 1, times 3 to the exponent 1 times 2 to the exponent x. The whole of this is 2 to the exponent x multiplied by 3 to the exponent x multiplied by 3 to the exponent x multiplied by 2 to the exponent 1. So this is what I meant, because at first I had 1 over there. Does it make sense in terms of what I've done over there?
Yes, sir.
So
Yes, sir.
let me also show you the other way that I meant. I wanted to say the whole of that is the same as 3 to the exponent 2x. This also is a plus in between, then it's 3 to the exponent 2x multiplied by 3 to the exponent 1 multiplied by 2 to the exponent x over 2 to the exponent x multiplied by 3 to the exponent 2x multiplied by 2 to the exponent that 1 over there, which means when we take out a common factor, guys, it's going to be 3 to the exponent 2x, which is 3 to the exponent 2x into, then this is where I can write 1 and say plus a, no, in this case it's going to be 3 to the exponent 1 because I took out that as a common factor, multiplied by 2 to the exponent x, the whole of this, 2 to the exponent x, 3 to the exponent 2x multiplied by 2 that. Then this is going to cancel that and that. Then we remain with the whole of that. I'm not sure if you notice what I meant when I said we're going to do it 2 times. There, we've done it once, but in this case, this is just going to cancel that and this. Then from there, it means you've got 3 to the exponent x plus 3 to the exponent x and all of that. Then you will still need to take out 3 to the exponent x again as a common factor because it's there and there. Then that 3 is going to cancel also that one. Then you will remain with this part. I'm not sure, guys, if it makes sense, guys. I'm just not sure if I'm not confusing you guys. Does it make sense, guys?
Yes, sir.
Yes, sir.
Okay, so let's maybe just continue. Let's maybe just continue with this one. So that means we're going to have 3 to the exponent x plus 3 to the exponent x multiplied by 3 to the exponent 1 multiplied by 2 to the exponent x divided by 2 to the exponent x. What is it? 3 to the exponent x multiplied by 2 to the exponent 1. So I'm going to continue with this one that I said you will still have to do it 2 times. So we take out this as the common factor again. Then you remain with 1 and everything else as it is. 2 to the exponent x, 3 to the exponent x, 2 to the exponent 1. This is equals to, they cancel again. Then you've got 1 to the exponent 3 to the exponent 1 multiplied by 2 to the exponent x divided by 2 to the exponent x multiplied by 2 over there. So, guys, can we further simplify this thing, or is that the end of it?
We can simplify it, sir.
What can we do? What could be our next step?
We have to add 1 plus 3. Then 2 will divide 4. 2x will divide 2x, and the answer will be 2.
So wait, you're saying this will cancel that, and this plus this, then we divide by 2, then it's 2.
Yes.
No, sir. The first step from here, we will add 1 plus 3. Then
it's
we will get 4.
Then it's 4.
4 times 2 to the exponent x times 2 divided by 2 to the exponent x times 2. Then 2x
So you're
will
saying
cancel
this
2x.
cancels, that cancel, then that divided by that, then you're saying we're getting 2.
Yes, sir.
Guys, you need to be very, 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 very careful. Very, very careful. Very, very careful. Very, 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 very careful. Who was Ntando? Was it you? In which grade are you, Ntando?
It's grade 11.
So, Ntando, Shias knows very well that in our grade 10th lessons, we emphasize the basics of maths, of which if you are not confident with those basics, you will create accidents the moment you become an engineer, Ntando. You need to be very, very careful. It's more like you are saying let's say we had 2 plus 3. Remember, this is a multiplication multiplied by assuming that this is 4. So it's more like, according to you, you are saying that is the same as you add that and that, it gives you 4, and you multiply by that 4, which is equals to 16. That is according to you, based on what you've explained there, of which BODMAS does not allow that, because BODMAS says you first sort out those that multiply, and then only after you can add with that one, which means 3 multiplied by that, it's equals to what is 12. So that means you have 1 plus 12. Only after you have multiplied, you can add with 1, which means it's 13. So can someone punch the whole of that and let me know if you are getting 16 or a 13?
I'm getting 13.
You're getting 16.
13.
13. Can you now see the mistake that you made? Do you now agree with me?
Yes.
So what I'm trying to explain, guys, is that you cannot say 1 plus 3. No. You have a multiplication sign in between. You remember, Shreyas, when I was explaining that the multiplication can be a times like that and a dot and nothing. Do you remember?
Yes, sir.
So this is where you guys need to be very, very, very careful. This is dangerous, guys. Very, very careful. You need to be very, very careful when it comes to that part. So let me try to think, because it seems like we cannot take out that as a common factor. I'm just...
So maybe you can take out the 2 to the exponent x at the top and the 2 to the exponent x at the bottom.
So you're saying I can do what?
You can strike out 2 to the
Like
power
that.
of x.
You mean
Yes,
cancel,
sir.
cancel?
Cancel it out. Yes, sir.
Another
Which
dangerous move, Shreyas. Another dangerous move. Let me also give you an example. So it's more like you have 1 plus 4 divided by 2. So according to what you are saying, Shreyas, it's more like you say we can say 4 divided by 2, which is going to be, what is it? It's going to be 2. So it's more like you say we're going to have 1 plus that divided by that, what is it? Is 2. Then we're going to have that, which is 3. Of which the danger with that, Shreyas, is that you cannot only divide that, but it has to be that plus that, which gives you 5. Then you divide by 2. That 2, which gives you, what is it? 2.5. Yes, which is 2.5, which is 3. And you can try punch the whole of this 3 and check maybe if you get 3 or maybe 2.5.
So for both, you get 2.5, 2.5.
Is it for both?
Yes, because 5 over 2 is 2.5, and 1 plus 4 over 2 is 2.5.
Wait. Let's see, Shreyas. Oh, yes. The whole of this and also this, you are getting 2.5. But can you see, if we divide that by that and also add with that, we get a complete different answer, which is not 2.5. So this is where it gets tricky, guys. And I think let's try to check what must be our final answer in this case. Let's substitute using 4. The other guys, let's maybe use 2. On that original equation there, I'm going to use 2. The other guys use 4. Fraction button 9 to the exponent, I'm using 2. Then plus 3 to the exponent 2 into 2 plus 1 over 18 to the exponent, I'm using 2, multiplied by 2 to the exponent 1 minus 2. So I'm getting 2. Which means when you use 4, when you use 3, any number, you must get 2. I'm not sure if you guys, you are getting 2 as well. What are you guys getting?
It was.
You are also getting 2, ne?
Yes.
So it means even when we substitute there, we must get 2. So the reason why I'm saying when we substitute it there is because at this stage we are not really sure if this is the end of it, or otherwise we were still supposed to be able to work it out. So let's try to also substitute there using the same number that you used. Myself, I was using 2. For those who are using 4, substitute 4. So it's 1 plus 3 times 2 to the exponent 2. At the bottom is 2 to the exponent 2 multiplied by 2. I'm getting 13 over 8, which means somewhere something went wrong. Can someone substitute again and see if you're still getting the same answer? Guys, are we still together?
Yes, sir.
What are you guys getting?
So when substituting with 4, sir, it gives me 49 over 32.
When you substituted with, what did you substitute with?
4.
Oh, okay. So this is an indication that somewhere we made a mistake. So let's quickly try to redo it as fast as possible. It's more like our final answer is supposed to be 2. I'm not sure, Shreyas, if when you substituted 4 there, you also got 2. Can you maybe confirm for me if you also got 2 when you substituted it there?
Yes, sir.
Okay, so that means we made something wrong somewhere. So now let's try to quickly correct it. So we've got 9 to the exponent that plus 3 to the exponent 2x multiplied by 3 to the exponent 1. Then we said 18. What was 18 here? We said 18 is 3 multiplied by 9. No, not 3, but 2. So let's say it's 2 multiplied by 9 to the exponent x, multiplied by 2 to the exponent that. Then we have 2 to the exponent negative x. Then next step, Let's see. Then we've got 9, which is the same as a 3 squared. And then again, that 9 over there is the same as 3 squared. Remember, guys, I'm just trying to take shortcuts so that we try to trace where we could have made a mistake. In case if you don't understand when I do these shortcuts, you can just let me know. So at the top, it means we've got 3 to the exponent 2x, which is that one, plus 3 to the exponent 2x multiplied by 3, the whole of that, divided by, this is the same as 2 to the exponent x multiplied by 3 to the exponent 2x multiplied by 2 to the exponent invisible 1, and that one, we can write it at the top as a positive exponent. Therefore, we can take out that as a common factor, which is 3 to the exponent 2x into 1. This is a plus. Then we've got 3 times 2 to the exponent x, which is that one there, over 2 to the exponent x, 3 to the exponent 2x, 2 to the exponent invisible 1. That cancels with that. Then we remain with 1 plus 3 to the exponent x over, we've got 2 to the exponent x multiplied by 2 to the exponent 1. I'm not sure, guys. This thing, was it the same as that one that I cancelled where I thought it was wrong? Is it still the same thing? Can someone try to remember if...
Yes, sir, it's still the same thing.
Oh, then it means we've done everything correctly. But now we need to find out what happened. So in the meantime, when I try something, can you guys, someone use maybe 5 there when you see x and tell me if you're also getting 2 or you're getting a different number? I just want to try check something here. X multiplied by...
It's 97 over 64.
So you're not getting 2,
97
ne?
Yes,
It's
sir.
not.
So it gives me 97 over 64.
Okay. Okay, let me try. Plus 3 divided by 2, that 2 there, then that cancels that, 2 to the exponent minus x plus 3 divided by 2. Can you maybe someone substitute there with that same number that you substituted with to see if you are getting 2 over there? Let's see, 2 to the exponent 2 to the exponent negative 2, at the bottom it's a plus 3.
Yes, sir.
Remember, tell me the answer so that I know.
It's 97 over 64.
97 over 64.
Yes.
No.
So,
I'm not
for the one
satisfied.
you...
Yeah.
Mm-hmm.
So for the... on the other slide, sir, that you... the last step, the way you drew the block on. So you said we must substitute it by 2 with the x.
No, that same number that you are substituting with over there to check if we're still getting the same answer.
Sir?
Yes.
Oh, okay, sir.
May you please go back to the step where we took out the common factor, which was 3 to the power 2x?
which was 3 to the power 2x. Yes, that one over there.
So I think we're not supposed to remove 2 to the power negative x to the top as a numerator. We were supposed to leave it there. We're going to be able to simplify and end up getting 4.
Let's try to guys, let's try. Where am I supposed to? Let me maybe remove all of these. Let's remove all of these and see where we will end with the guidance of Lerato. So Lerato, now you'll guide us in terms of in which direction to go. So let's say, obviously, at that step, we've got 3 to the exponent 2x plus 3 to the exponent 2x multiplied by 3 to the exponent that. So you're saying here, we are, then what am I writing there, Lerato? Is it 2 times 3 to the exponent 2x?
It's 2, yes, 2 to the power 2x, yes, 2 to the power x.
Then 3 to the exponent 2x, 2 invisible 1 multiplied by 2 that. Yes. Then from there, what happens?
So we take
So
out
we can take it out.
at the top. Yes.
We take out its common factor, ne?
Yes.
Okay, 2 to the exponent. Guys, make sure that you are following and understanding what we are doing on this step. I've just noticed something, and I'm glad you were able to notice something. Obviously, there is 3 to the exponent 2x times 2 that times 2 invisible that. So now let's see. So obviously you are saying, Rato, this cancels, ne?
Yes.
Sure. It's coming out nicely. We've got 4 over there divided by. So you multiply the same basis, you add the exponents. So
Yes,
obviously it's 2 to the exponent that plus negative x, which is that one. Then it works out to be 2 to the exponent 0, which is equals to 1. Yes, then it becomes 1 multiplied by 2, which is the same as 4 over 2, which is equals to a 2, of which is that final 2 over there. So, ladies and gentlemen, can you see that when all of us participate, we are able to come out of something positive? So now I want us to learn from that mistake that I made. Lerato, make sure that you understand where I made a mistake and also how you learn from the mistakes that you made. Everyone else, please do pay attention to this one. I want that step. Okay, let me just do this. Remember, there was that step where I took that to the top. So let me maybe write that step over there. So this is a, what is it? I'm going to bring it down. I want to show you exactly where I made that mistake, because I do notice what went wrong and I want to correct it so that you see that even if you take it to the top, multiplied by 2, that multiplied by 2 minus x. Yes, this is where I want us to have a look at it. So, Lerato, the reason why I took it to the top, obviously, is because of that rule, but I want you to notice my mistake. When you take it to the top, guys, because of that positive sign, you cannot take it to the top to either this side or that side. It has to multiply everything at the top. Unlike when we had just a dot throughout for the numerator and again a dot throughout at the bottom. Which means if I wanted to write it to the top, I was supposed to do this to say, obviously, we've got 3 to the exponent 2x at the top. plus let me have enough space over there and say plus 3 to the exponent 2x multiplied by that to the exponent that, the whole of this to the exponent 2 that 3 to that multiplied by 2 that. So guys, remember, I wrote it at the top. So I must put it in brackets and say 2 to the exponent x, not just writing it as 2 to the exponent positive x and only attach it to that, because we've got a positive sign in between, unlike if it was just a dot. If it was a dot, then I could have just written it there, no need for the brackets. But because it's a sign of a plus or a minus, you have to do it that way. Let's continue. You will see what happens. Then it's obviously that multiplied by that, that c multiplied by that. We were going to have 2 to the exponent x multiplied by 2 to the exponent x plus 3 to the exponent 2x multiplied by 3 to the exponent 1 multiplied by that again. Then you say over 2 to the exponent x multiplied by 2 to the exponent that multiplied by that. Then that's when you can take out the common factor, which is that and that, because is there, is there, is there, and again is there. So that means you've got 3 to the exponent 2x multiplied by 2 to the exponent x as the common factor. Then you've got 1 plus 3 divided by 2 to the exponent x multiplied by 3 to the exponent that multiplied by 2 that. So can you see, this cancels that and this cancels that. Then you've got 4 divided by 2, which is equals to 2. Guys, Lerato, did you notice my mistake? And again, did you learn something out of my mistake?
Yes, sir.
Same question goes to everyone else. Did you guys understand that mistake that I made? And again, does it make sense where the mistake was made and how it was supposed to be done?
Yes, sir.
Yes, sir.
Yes, sir.
100%. So guys, can you now see that out of that mistake, we learned that when you write this thing at the bottom to the top as a positive exponent, if you've got a sign over there, don't just write it. But the correct way of doing it is how Lerato explained it. When you've got a positive, a sign of a plus or a minus, either at the top or at the bottom, don't worry that much about having a negative exponent. Don't try to move it to the other side to write it as a positive exponent. Just leave it wherever it is. Even if it's that one where you've got multiplication and you don't have a sign of a plus or a minus, no need for you to write this as a positive exponent. You can just work it out until you get to that stage where you say same basis, they subtract each other over there. So it doesn't really matter in terms of which approach, but it seems like when you've got a positive sign or a minus sign, it's very dangerous for you to be moving it to the other, either to the numerator side or the denominator side, with the aim of writing it as a positive exponent. So guys, can we now move to the next question? I want us to do everything so that we know with simplification you are done. You won't struggle when it comes to solving for x. So guys, do we do everything, or otherwise what is it? Do we leave it here and I leave it for you guys to continue? I mean to continue. Guys, if it's for me, I'm going to choose to continue with everything so that we don't fall behind. Who else is there? Ntando, what do we do, my man? Do we end it here? You will finish the rest, or otherwise should we quickly hammer everything? What do we do?
Let's continue, sir.
So we are left with 3 more problems. So let's see. We've got 3 times 2 to the exponent x minus 2 to the exponent x minus 1 divided by 2 to the exponent that plus 2 plus 2. Okay, so let's see. Obviously, the bases are in the simplest form. What we can do is just to separate the exponents. That, then we've got 2 to the exponent that. So can you see in this case, we've got a plus or a minus at the top and at the bottom. So we can just easily take out a common factor there, which is that we've got that minus a 2 to the exponent that. Also here we can take out common factor as 2 to the exponent that. Then we've got a plus that. This cancels that. Then we've got 3 minus, this is 1 over 2. Let's see. You can just say 3 minus 1 over 2. 3 minus 2 to the exponent negative 1 is 5 over 2, which means you've got 5 over 2, which is that at what is it? That at the top. So you can just say divided by this at the bottom. This plus that is 4 plus 5 is 5. So you remember, guys, when you have a multiplication sign, this is the same as that. You can say 5 over 2 multiplied by, you just swap those things. Then that divided by that, then you cancel, you've got 1 over 2. Guys, someone joined a lesson and they are not unmuted. Remember, guys, in case if you have joined this lesson and you don't mute, if I mute you, you won't be able to communicate. Caroline, can you mute your mic? Because if I mute it from my side, you won't be able to communicate in case if you want to ask a question. Let's see. Okay, muted. So, guys, did all of this make sense for everyone before I move to the next problem? Because it seemed to be easy. Did it make sense, guys?
Yes, sir.
100%.
Sorry, sir.
Mm-hmm.
How did you get 5 over 2?
Oh, how did I get 5 over 2? It's when you punch the whole of that at the top. So when you say 3 minus 2 to the exponent negative 1, check how much you get. So this is where I get 5 over 2. Then this one, it gives 5. So remember, in between, you've got that divided by. So it's more like this is 5 over 2, then over 5. Are you getting 5 over 2 when you punch that?
Yes, sir.
So now it makes sense, ne?
Yes.
Okay, so now let's move to the second last question. What are we having, guys? So let me see. We've got 4 to the exponent x plus 2 to the exponent x minus 1. Shreyas, is everything making a sense? Because I know you are in grade 10, but this is grade, I can say grade 11, combination of grade 11 and 12 stuff. So if you are able to understand all of this, then it means you will be excelling in your grade 10. And when you get to grade 11 and 12, you won't struggle with this stuff. So guys, let's see. Same approach also. Let's see. Obviously, we know this is the same as 2 to the exponent 2x, that part alone. So we've got a plus, this is 2 to the exponent 2x multiplied by 2 to the exponent minus 1. Shreyas, did you understand that part of 2 to the exponent 2x?
Yes, sir.
And also this part, did you get it?
Yes, sir.
Okay, 100%. So this is what we've got. Obviously, also there we take out common factor of that into, then we have 1 there. because we took out that, and we also have 1 there multiplied by that, which is over 2 that multiplied by that. This cancels. It's equals to, you've got 1 plus that. This is the same as 3 over 2. That one down to the bottom. Remember, 2 to the exponent minus 1 is the same as 1 over 2. So it's more like 1 plus half is 3 over 2 divided by this thing at the bottom is the same as half, which means this is the same as 3 over 2 multiplied by 2 over 1, which is that, and this goes into that is 3. So I'm not sure if you guys agree with me on this one. Does it make sense for everyone?
Yes,
Yes,
sir.
sir.
Yes, sir.
So you now remember that, okay, let me see. Promise, if I substitute any number there in place of x, what am I supposed to get?
You're supposed to get 3, sir.
Is she right, guys? Is that correct, what she's saying?
Yes, sir.
Second confirmation.
Yes, sir.
Yes.
100%, which means we are all on the same page, guys. I'm very much happy because I won't struggle that much to make you understand the part where we are now solving for the value of x with this type of problems. So that by that plus 3 to the exponent x minus 3, the whole of this divided by 2 to the exponent 3, that minus 2. Obviously, same approach also. Let's see. We are going to have 2 multiplied by 3 to the exponent x multiplied by 3 squared, yes, plus 3 that multiplied by 3 minus that, the whole of this, that multiplied by 3x, 3 minus 2. So what else? Obviously, to take out a common factor, which is 3 to the exponent x. There, then I'm remaining with 2 multiplied by 3 squared is 9. Plus this one is, what is 3 cubed, guys? Is it 27? 3 to the exponent 3. Yes. So that means this is the same as 27 to the exponent minus 1. Otherwise, you can write it as 3 to the exponent negative 3. Then we've got 5 multiplied by 3 to the exponent x. What is it? This is 9. So this is the same as 9 to the exponent minus 1. And then that cancels that. Then you have 2 times that, which is what? 18 plus the whole of that. So you can just say maybe 2 times 9 is equals to 18 plus 27 to the exponent, to the exponent negative 1. At the top, I'm getting 487 over 27, then divided by the whole of this. Remember, this thing is the same as 1 over 9 times 5. Okay, no, I almost forgot that 5. So I'm going to say 5 times that. 5 times 9 to the exponent negative 1. So this is the same as 5 over 9. So this is the same as 5 over 9, which should be 487 over 27. You multiply by 9 over 5, which is equals to, then you can punch 487 at the bottom, 27 multiplied by 9 over 5, it's a number which is in a form of a decimal, which is 487 divided by 15. Guys, I'm not sure if this is the correct answer. And for that reason, I'm going to run a test. Someone use 3, someone use 5, someone use a 4. So myself, I'm going to use 4. Let's see. Let's substitute it there. I'm sure you know what I'm talking about, guys. I'm using 4 plus 2 plus 3 to the exponent 4 minus 3. At the bottom is 5 multiplied by 3 to the exponent 4 minus 2 is equals to 487 over 15. It seems like this answer is correct. I'm not sure about those who are using 3 and 5.
It's correct, sir.
Just have number 15, sir.
Ladies and gentlemen, for today's lesson, would you say you understood everything? Were you not guys confused?
Yes, I understand.
Wait, sir. And we learned.
Yes, sir.
So I've also learned a lot, guys, out of this lesson. I don't think when we get to that part where we'll be doing the solve for X type of questions, we'll struggle. Just make sure that you don't miss that lesson, because once you do, it becomes a bit of a challenge, especially for those who try to join this lesson. They wouldn't survive because they missed those previous lessons, of which, in case if you missed a lesson, it's always best to first catch up, and then from there you will easily be able to understand this type of lessons. So guys, I hope you enjoyed this lesson as much as I did, and I thank you for joining this lesson. Just for my record, guys, whoever who attended this lesson this far, just make a comment in the group. Doesn't matter whichever comment that you made, or you may just make a comment. I'm going to use that information to know who attended until the end of the lesson and everything. So guys, don't forget to make a comment if you attended up until this far. So guys, this brings us to the end of our lesson for today, and have a good night, guys. I'm stopping the lesson.